Notes 5.5. We're going to solve exponential and log equations and inequalities. In 5.2, we did these already. We tried to get the same bases. So for example here, 25 is the same as 5 squared, and 125 is the same as 5 to the third. So exponent to next to you multiply. So basically 5 to the 2x is equal to 5 to the third. So when I solve this, I know for these to be equal, I know that 2x has to be equal to 3. Therefore, x is equal to 3 halves. Okay. This one here, to get the same bases, I'm going to say my base is going to be 3. You could use 1/3, but I'm going to use 3. So this would be the same as 3 to the negative 1. So really just negative x, exponent to exponent, you multiply. And 81 is the same as 3 to the 4th. Okay, so now I have the same bases, therefore my exponents have to be equal. So negative x is equal to 4, therefore x is equal to negative 4. Okay, this one right here, I'm going to get 3 over 2 is my base. So this here is cubed. 3 to the third is 27, 2 to the third is 8. And here I have 3 over 2 to the x plus 1. To make those equal, I have the same bases. Therefore, I know that x plus 1 has to equal 3x. Subtract your x over, so you get x is 1/2. Okay, so we did some like those. But what if you don't have the same bases? Okay, what if I can't get the same bases? Like 7 and 12, there's no way I can get them both to be the same bases here, really, right? Okay, so what we're going to do, we can do two different things here. We're going to use natural log or the common log. If I use natural log, say I have 7x is equal to 12, right? So what I can do is I can take the natural log of this side, and I can take the natural log of this side. Okay? Sorry, this is 7 raised to the x, not 7x. Okay, now using the power rule, this is the same thing as x times natural log of 7. And over here, I'm just going to, I put it over there, but really it should be in front. This is the natural log of 12. Now to get x by itself, all I have to do is divide by this natural log of 7. So I get x is equal to the natural log of 12 over the natural log of 7. Okay, and if you put that in Desmos, it's approximately 1.277. Okay, you can do the same thing with common log. Okay, if 7 to the x is equal to 12, if I take the log of this side and the log of this side, okay, same sort of idea here. I can take this x, put it out front. X is equal to, x times log 7, using the power rule, is equal to log 12. And really you could do this with base 2, base 10, anything, as long as you're doing it to both sides of the equation, right? So x is going to equal log of 12 divided by log of 7, which also it gives you the same thing, approximately 1.277. When we're doing the inequalities, we want to look at the graph of it. Okay, so if I take this and I subtract this over that side, I have 7 to the x minus 12. Okay, so if I graph this equation right here, it looks like this. Okay, and I know that the asymptote here is at negative 12. We talked about the graph of the exponent, right? Exponentials. So we have so yeah, kind of goes like this, right? If you look at it, it's going to cross right here at 1.277. Okay, and where is it going to be less than 0? It's going to be less than 0 for all these x's over here, right? So it's going to be for all of my x's from negative infinity up until 1.277. Or if you want to exactly, you could say the log of 12 over 7, log of 7. Okay, and where is it going to be greater than? So if I take this minus 12, where is that going to be greater than 0? Greater than 0 is over here, and it's going to keep going up. So that is basically from your 1.277 through infinity. Okay, next problem here. Okay, we got two exponents here. You can use either one. I'm just going to use log. Okay, so I'm going to say the log of 2 to the 3x plus 1 is equal to log of 3 to the 4 minus x. Okay. Using the power rule, I'm going to take this exponent, put it out front. So this is 3x plus 1 times log of 2. And this out front, power rule again, 4 minus x times log of 3. Okay, now I'm going to use the distributive property. Okay, if I take this times this, this is 3x times the log of 2 plus log of 2 times 1. Same on the other side. 4 log of 3 minus x log of 3. Okay, if I move all the x's to one side and all the other numbers to the other side, really think about these as just numbers, right? If I have 3x times some number, right? Okay, so I'm going to bring the 3x, I'm going to bring the x's to the left side. I don't really need the parentheses there, but you can. And I'm going to bring the numbers over here with no x. So I'm going to take this, I'm going to subtract it over there. Okay, if I factor out an x here, this is going to be x and 3 log 2. Okay, and then to get x by itself, I can just divide this. Okay, so my x is going to equal, I'll just shorthand here, this divided by this. Okay, so there is my answer. X equals that. If you put that in your calculator, put that all in there, it's approximately 1.1765 or whatever. Yep. Okay. Now we could just keep going with that as well, using our quotient rule and other things. I know that this part here is log of 3 to the 4th power, using the power rule, minus log of 2. Okay, here this would be log of 2 to the 3rd plus log of 3. Okay, this is the same thing as 81. That's the same thing as 8. And then using the subtraction there, okay, this would be log of 81 divide by 2, right, since it's subtraction divide by, over the log of adding would be multiply, right? So 8 times 3 is 24. Whoop, I did all that, you couldn't see it. Okay, this would be 3 to the 4th, which is 81. This would be 2 to the 3rd, which is 8. Multiply with subtraction, it's division, so 81 divided by 2. And with this is multiply, right? Adding is multiply, so 8 times 3 is 24. Okay, number 5. I'm going to use the quotient rule here, subtraction. So this is going to be log base 3 of x plus 6 divided by x plus 2. Okay, we had a property that we talked about, that if they're the same bases, we can set these equal to each other. So I know that this has to equal x. If we cross multiply, I know that x times x plus 2 has to equal 1 times x plus 6. Then I just have a quadratic to solve, right? This is x squared plus 2x. Subtract the x over, minus the 6. Factor it, and I get x equals negative 3 and negative 2. Okay. If you think about these two equations right here and the domain, to a negative, I'm sorry, I factored that wrong. This would be, okay, so negative would be minus 2 here, right? So this would be a positive 2. Okay, so negative 3 and positive 2. Negative 3 is not part of the domain. Okay, it's going to, yeah. Anyway, if you would graph it, it's negative 3 is not part of the domain. It's not part of the x value, so it can't be an x value here. But 2 does work, so I know that 2 works. So you can also just take it and plug it in here and make sure that one side of the equation equals the other side of the equation. Okay. Okay, next one. We can use since this is plus there, we're going to use the product rule. I know this is log, base 10, right, common log, of 3x plus 2 times x minus 1. Okay, if I multiply, well, okay, let's use, since I know this is base 10, let's take this and rewrite it as an exponent. So I know 10 to this power, right, 10 to the first is equal to this part. And I'm going to multiply it together here. So it'd be 3x squared minus 3x plus 2x would be minus 1x minus 2. I know 10 to the first power is just 10, so if I subtract that over, get it equal to 0 to solve. And then I can try and factor it, which is not going to work, which means I have to use the quadratic formula. Which is always fun, right? So negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. And I get 1 plus or minus the square root of 145 over 6. And that does not simplify. Okay. Okay, so the 1 minus is not part of the domain, so it's really just 1 plus square root of 145 divided by 6. The minus 1 does not work there. By the way, this is about 2.174 if you put it in Desmos and work that out there. Okay, next problem, we're going to solve where it's equal and then less than and greater than or equal to. Okay, so with this one, first thing I'm going to do is divide everything by add the 15 over, and then divide everything by 3. Okay, trying to get this log part by itself. So I know it's log base 2 of 2x. 15 divided by 3 is 5. Okay, now I'm going to rewrite this as an exponent. So it'd be 2 to the 5th power is equal to 2x. 2 to the 5th power is 32, and divide gives me 16. Okay. Now, next I'm going to look at the graph on Desmos. By looking at this graph on Desmos, okay, it goes like this, and you can see this point right here is 16. Okay, easy way to make sure you're right. Okay, and then where is it going to be less than 0? Less than 0 is right here. And if you remember, we have an asymptote here, right? Okay, so it doesn't go past 0, it doesn't go over here. So basically from 0 to 16, that's where it's going to be less than 0. And then greater than 0 is going to be from 16 through infinity. Okay, now this does say or equal to, so I'm going to use the bracket there for my interval notation. Okay, number 10. Okay, I'm going to take this, I'm going to use the power rule to bring that up top there. So this is the same as e ln x to the negative 2. Remember, e and natural log are inverses of each other, so those kind of cancel each other out. So I have x to the negative 2 is equal to 1 over 16. Yeah, so I want to solve this equation here. Different ways you could do it. I would do this, right? Negative 2, it means 1 at the bottom. So I know that x squared has to equal 16. Therefore, x is equal to plus or minus 4, square root of both sides. Okay. And if you look at Desmos for this graph, it does go through at both 4 and at -4 to verify your answers there. Okay, this one right here, and once again, I know that natural log and e are inverses of each other. It's kind of like we did there, right? So this means the exponent just kind of comes down. Okay, using the quotient rule, subtraction here, I know that this is going to be the natural log of x over x minus 3. Since they're both natural logs, I can say that x over x minus 3 has to equal 2. The way I would solve this is say 2 over 1 and I cross multiply. So that x times 1 is x is equal to 2 times your x minus 3. Okay, subtract that over, you get x, add that over, you get 6. Okay, and the next one here, number 12 that I have, with this one we're going to use a substitution sort of idea. We did this a little while back with some of our quadratics, but anyway, we'll think of through here. Okay, this right here is the same thing as e to the x squared, right? So basically, if I say that, let's say something like u is what e to the x is. So really I have u squared here minus 4u, e to the x is a u, plus 3. Now I have a basic quadratic to solve. Sorry, not x, but u. Okay. Now I can take this. I know u is equal to e to the x. So I know e to the x equals 3 and e to the x equals 1. Okay. So using that idea of the substituting, putting something in its place to get a quadratic to solve out, and then substituting it back in. Okay, so now if I take the natural log of both sides, okay, the natural log of both sides, those will cancel out. I get x is equal to the natural log of 3. And over here, natural log of both sides, they're inverses. You get x is equal to the natural log of 1. Okay. Natural log of 1 is just 0. And here you get natural log of 3. So to kind of summarize kind of the techniques that we just used, if it's in this form, okay, if it's an exponent, right, you got your function up here, you got your x up in the variable, right? So 2 to the x equals 8 or whatever. If you want to solve for this x, the best idea is to take log of both sides. You could take log base whatever, or natural log even too. Okay, remember we did that in this first problem here, right? Okay, so if I have this, take the natural log or the log of both sides, both of them work to solve it that direction. Okay, so if it's just an exponent, use log. If it's e, you definitely want to use natural log. Okay, that's definitely what you want to use there. Okay, if you have log of the same bases, okay, same both base a or base 2 or whatever, then you can just say f of x is equal to g of x and solve it. And if you have the log of something equal to something else, change it to an exponent, you know, a to the b power is equal to f of x, and then solve it from there. Okay, so that's kind of how you, thinking about how you can solve it there. Okay, number 13, the strength of a habit. Okay, this is getting into psychology here a little bit. The strength of a habit is a function of the number of times the habit is repeated. The more often you do something, the more of a habit that's formed, right? If n is the number of repetitions and h is the strength of the habit, then according to this psychologist, k is a constant, we have this equation that works. So let's take this equation and solve for our k, our constant. Okay, so to get all this by itself, let's divide by the 1,000. Okay, let's take your 1 over the other side. Get rid of the negative. So I'm just going to make that be a positive 1. That'd be a negative. It doesn't really matter which way you do it, but this is one way. Okay. Now, notice we have e. So if you're looking at the ways we solve here, right, we have an exponent. So if we have an exponent and if it's an e, we definitely want to use natural log. So I'm going to take the natural log of both sides. Okay. So here I have natural log of 1 minus h over 1,000 is equal to negative kn, because natural log cancels out the e, right? Okay, and lastly, to get k by itself, I divide by negative n. Different ways you could write it. We'll just do it like this. Natural log of 1 minus h over 1,000 divided by negative n. And there we have our constant then. Okay, number 14, last problem for today. A study monitored the lifespan of 129 robins over a 4-year period. The equation below, this one here, was developed to calculate the number of years it takes for X% of the robin population to die. What percent of robins died after 6 months? Okay, so 6 months is a year. So it says y in years, so this would be half a year. So we'll say 0.5. Okay, so we want to solve for x here, right? Okay, so what I would do is I'd multiply both sides by the 0.42, and 0.5 times 0.42 gives you 0.21. Okay, and I would add the 2 over to the other, or subtract the 2 to the other side. So that'd be negative 1.79. I'd get rid of this negative, so divide by negative makes 1.79. Okay, now thinking about the strategies we've used, right? We have a log of something equal to some number. So we said we're going to change it to an exponent form, right? Okay, so remember log is just like base 10. So this is the same as 10 to the 1.79 is equal to 100 minus x. Okay, so getting x by itself here, I'm going to add that over this way, so I get x equals 100 minus 10 to the 1.79. Okay, which if you work it out on Desmos is about 38.3. So about 38% of the robins will be have died after half a year, after 6 months. Okay, those are notes 5.5.